All right, welcome to the explainer. Today, we're diving into a molecule that, we see every single day. It seems so simple, but it's secretly one of the most powerful and complex things on our planet. It's literally everywhere, it's inside of us, but what really makes it so special? Let's find out. Okay, let's kick things off with a little riddle. I want you to think about this. What molecule is polar? It's got a V shape. It covers about 3/4 of our planet, and it is the sole reason that life as we know it can even exist. Any ideas? Of course, it's water. But here's the thing. We're not going to just stop there and say, yup, water's important. Today, we're going to dig deeper. We're going to uncover the source code, the secret recipe that gives water all of its amazing superpowers. So we solved that first riddle. But really, that just opens the door to the next big mystery. How does water actually work its magic? Well, it turns out that the answer to pretty much every question about water's weird and wonderful properties, it all comes down to one single concept. This is the secret ingredient, the key to the whole thing: polarity. So what even is polarity? It's actually pretty simple. It just means that inside the molecule, the electrons aren't shared evenly. Because of this imbalance, you get a molecule with two different ends, or poles, one that's a little bit positive and one that's a little bit negative. Kind of like a tiny, tiny magnet. And if we look inside a water molecule, H2O, you can see exactly how this works. That big oxygen atom in the middle is super electronegative, which is just a fancy way of saying it's really greedy for electrons. So it hogs them, pulling them away from the two smaller hydrogen atoms. This makes the oxygen side slightly negative and the hydrogen sides slightly positive. And this is where the magic really happens. That tiny charge difference makes water molecules incredibly attracted to each other. The positive hydrogen of one molecule gets drawn to the negative oxygen of another. This special little connection is called a hydrogen bond, and trust me, it is the key to everything that's about to follow. So how does a hydrogen bond turn into a superpower? Well, first up, thanks to those bonds, water is incredibly sticky. It has this amazing ability to stick to itself and to other things. If you want to see this in action, just think about a giant redwood tree. I mean, have you ever really stopped to wonder how water gets all the way from the roots in the ground to the very top leaves? Like 300 feet up in the air? It's fighting gravity every single inch of the way. How does it do that? It's a beautiful process, sometimes called the water ladder. So first, you have adhesion. That's water sticking to the sides of the tiny tubes inside the plant. But at the same time, you have cohesion. That's water sticking to itself, which creates this long, unbroken chain of water molecules. So when one molecule at the top evaporates from a leaf, it literally pulls the entire chain up behind it, just like beads on a string. It's a perfect, silent, natural pump. And that same stickiness from cohesion is also responsible for something called surface tension. The molecules on the surface are pulled so tightly together that they create this kind of skin. It's so strong that it's how insects like water striders can literally walk on water. Pretty cool, right? Okay, so water stickiness doesn't just apply to itself. That polarity we talked about also makes it fantastic at pulling other molecules apart. This superpower makes it the universal solvent, and it's absolutely critical for life. Just think about stirring salt into a glass of water. Salt is an ionic compound, so it dissolves almost instantly. Why? Because water's little positive and negative ends literally surround the salt ions and just pull the whole crystal apart. But then you have oil, which is nonpolar. It doesn't have any charge for the water molecules to grab onto. And that's exactly why oil and water will never mix. So why does any of this matter to you? Well, your body is mostly water. Water is the solvent that carries crucial nutrients to all your cells. It's what allows your kidneys to filter out waste. It's the foundation of your blood, your saliva, pretty much all your body fluids. It's the stage on which the entire chemistry of life plays out. Okay, for our third and final superpower, and this one is a biggie, let's look at how water acts like a master thermostat, regulating temperature not just on a global scale, but inside our own bodies too. One of water's strangest and most vital properties is captured perfectly in this story. Someone looked at their frozen pond, worried about their fish. only to see them swimming around just fine under the ice. It looks like a miracle. So how is that possible? Why does ice float? The answer is all about density. Here's the crazy part. Unlike almost every other substance out there, water actually expands and becomes less dense when it freezes. Those hydrogen bonds lock into place, forming a crystal structure that holds the molecules farther apart than when they were liquid. And that's why ice floats. It creates this amazing insulating blanket on top of lakes and ponds that protects all the life underneath from freezing solid. But that's not all. Water also regulates temperature because it has a high specific heat. Basically, that's just a measure of how much energy it takes to change something's temperature. And for water, that number is insanely high. It can absorb a ton of heat without getting much hotter, and it can lose a ton of heat without getting much colder. The effect of this is just massive. On a global scale, it stabilizes temperatures in our oceans and lakes, preventing these wild swings that would be deadly to life. And on a personal scale, it's what helps your body maintain a stable internal temperature, which is absolutely vital for you to stay alive. And just how resistant is it? Well, specific heat is the energy you need to raise 1 gram of a substance by just this much, 1 single degree Celsius. For water, the amount of energy required to do that is incredible, making it one of the best temperature buffers on the planet. And one last thing on temperature, evaporative cooling. When water evaporates, it's the molecules with the most energy, the hottest ones, that leave first as gas. And when they go, they take their heat with them. This is exactly how sweating cools you down. So let's just recap water's incredible resume. All of these superpowers. The fact that it's sticky, that it can dissolve almost anything, that it floats when frozen, and that it controls temperature, every single one of them traces back to that one simple feature, its polarity, and the hydrogen bonds that come from it. It's a perfect, elegant chain reaction. And that really leaves us with a final thought to chew on. Water's incredible, life-giving complexity is so beautifully hidden in its simple 3-atom structure. It makes you wonder, what else in our world works in these kinds of secret, elegant ways to make all of this possible? Thanks for joining us on The Explainer. Stay curious.